Yeah. So what I was saying is I have combined the notes from 7th class, whatever we discussed so far about the types of chemical reactions. Okay. All the types of chemical reactions like combination, decomposition, displacement. These three we have discussed. Double displacement we started. I gave one example. I'll give more examples today. And we talked about a little bit about definition of precipitation reaction also. And then we'll discuss the last one, which is oxidation reduction. Okay. So I've combined all that note here. I will write in this note itself where we had stopped in the previous class. Double displacement reaction. Do you people remember? Silver nitrate, sodium chloride. What happened? Silver went and took the place of sodium here, and sodium came and took the place of silver. So it became silver chloride and sodium nitrate. And silver chloride, it was white precipitate. It did not dissolve. NaNO3, this was a solution in which this solid was there, which did not dissolve completely. So it made a white precipitate. And wherever in some reaction, if precipitate is formed, then it becomes an example of a precipitation reaction as well. Okay. So this is a double displacement reaction also, and precipitation reaction also. Double displacement because Ag is displacing sodium, silver is displacing sodium, and sodium is displacing silver. So both of them are displacing each other. And there is a precipitate formed. Okay, so remember, precipitation reaction, most of the double displacement reaction, they are also examples of precipitation reaction because in most of them there will be some precipitate form. All right, so I'll give you one example, I'll give you more examples. Keep this in mind, these are all examples of double displacement as well as precipitation. So first one I had given here. Let's start with the second example. What will be this compound name? Tell me.
Barium chloride.
Yes, barium chloride. And this one?
Sodium sulfate.
Yes, sodium sulfate. So what should be the product?
Sodium chloride and barium sulfate.
Yes. Barium will go and take the place with sulfate. So this will become BaSO4. Okay, so it will become barium sulfate, and sodium will combine with chlorine. Anyone remembers what should be the formula for sodium chloride?
NaCl.
Yes, it will be NaCl. Don't think that we have to write Cl2 because it is barium chloride. So when barium reacts with chlorine, it is BaCl2, but when sodium comes with chlorine, the formula for that is NaCl. Okay, now is this reaction already balanced? Can you check?
Yes, sir.
See, barium, there is only one, no problem. Sulfate also, fine. Chlorine, there is two, here only one. Sodium also two, this side is only one. Is it balanced?
No, sir.
It's not. So what? How do you think we can balance it?
We can put 2 in front of NaCl.
Yes, very good. All we need to do is just put a 2 over here. So now sodium also becomes 2, like this side. Chlorine also becomes 2, like this over here. So now it is balanced. So do I need to write the names? Everyone has got it. Barium chloride, sodium sulfate, and sodium chloride. I think these compounds names are clear, or should I write it, guys?
Sir, I have a doubt.
Write it, sir.
Write it. Okay. Yes, tell me. What's your doubt?
Sir, last year when we were writing the elements in their chemical formula, that time we wrote Na2 and Cl2. Since 2 is common in both, we did not write it. So that time we wrote it just NaCl. Then why should we balance it in?
Okay. 1 minute. So are the names readable?
Yes, sir.
Let's switch this thing a little bit. This is solid. And NaCl. It is aqueous. Now this barium sulfate, which you see, we had seen this barium sulfate in the not yet. Okay, it's not yet seen. Okay, this barium sulfate is also a white precipitate. Okay, this is also a white precipitate. So that's why this is also an example of a precipitation reaction, along with being an example of a double displacement. Okay, now, Kavya, you were saying you were writing Na2 and Cl2 like this, or you were writing Na2 plus and Cl2 minus, something like this in your previous class. What did you see? Did you see something like this or this? Do you recall? Kavya, you were asking a question, right?
Yes, sir. Like, I don't remember.
Yeah, that's okay. So this one is wrong. This was never the formula. Na2Cl2, this is not the formula. You never write like this. Maybe you would have seen something like this, Na2 plus and Cl2 minus. But that is also not right. It should be a plus and a minus. Only one, plus 1 and minus 1. Sodium has a valency of 1. Chlorine also has a valency of 1. So you should not see this Na2Cl2. Okay. I don't know, maybe you're confusing with something else. Okay, NaCl always has this formula only. And if you remember, I had told you what is the atomic number of sodium?
Eleven.
Yes. Sodium is 11. So what will be the electronic configuration? 2, 8, 1, right? 2 plus 8 is 10 plus 1, 11. So in the outermost shell, it has 1 electron. And what about chlorine? What is the atomic number of
17.
chlorine?
17.
17.
And the electronic configuration is 287. Okay, so if you try to draw the nucleus of this sodium, this is the nucleus, let's say, and I'm drawing only the outermost shell, so it will have only 1 electron. And for chlorine will have 7 electrons. So what does it do? Sodium gives away this electron and chlorine accepts that electron. Because of that, what happens? Sodium becomes Na plus and chlorine becomes Cl minus, and they make a ionic bond. by giving and taking of electron. So this is how the bond is formed between Na and Cl.
Sorry, sir, I confused it with calcium oxide where we write Ca2O2 and that's 2 we don't write since they are common between them.
Okay, that's okay, not a problem. So the doubt is clear, right?
Yes, sir.
Okay. So what should I do? Should I keep this over here? Delete it.
You can delete it, sir.
Anyone needs this? I think I had explained this earlier also. If somebody needs it, you can take a screenshot of this one. I don't want to keep it over here because it will confuse you from the topic which I'm doing right now. It's slightly different. So if somebody needs this, take a screenshot of this one. This is how the bond is formed between Na and Cl, sodium chloride, the common salt. Okay. So this was your second example. Let's move on to more examples. Who will tell me what will be the product here?
Barium sulfate,
Yeah, write it
copper.
down, all of you. Write down what will be the product. Write down the product for both of them. Tell me, what all did you write for the third one? What is the product?
Barium sulfate plus copper chloride.
Tell me the formula.
BaSO4
Plus,
is it CuCl2?
yes, Cl2. Copper chloride is like this. Copper has a valency of 2. Okay, I will share that
Sir,
valency.
but why here only we are writing CO2?
Okay, repeat your question again, Nitya. Your voice was breaking. I couldn't hear you. Say that again.
Sir, like, why do here only we write Cl2?
See, every element reacts with Just a minute, guys. Some noise over here. Let me close the door. Okay. So what I was saying is, just now you saw I gave you an example of sodium reacting with chlorine, right? When sodium reacted with chlorine or bonded with that, not reaction basically, sodium and chlorine, that's not called a reaction, that is bonding. Okay, ionic bond was formed. So sodium had 1 electron in the outermost shell, chlorine needed 1 electron in the outermost shell. It was already 7, it needed 1 plus 1 so that it will become 8, right, to make the octet. But what happens with your copper? When copper comes in contact with chlorine, copper has actually 2 electrons in the outermost shell. 2. And it wants to lose both of them. So what will happen? One chlorine atom can take only 1 electron, right? Because it is already 7, but it can take only 1. So one chlorine atom takes this 1 electron and it needs another 1 more chlorine atom to take the second one. That is why 1 atom of copper bonds with 2 atoms of chlorine. That is why the formula is CuCl2 and not CuCl. Does that make sense?
Yes, sir.
Okay. So that is the molecular formula for copper chloride, and it will always be same. No matter which reaction you are in, copper will always bond with chlorine in the same manner. Copper chloride will be CuCl2. Okay. So barium sulfate, already you know the names, so I'm skipping this one. This barium sulfate you already know. Copper chloride I have not written before. So let me write it. Copper. And remember, this will be white precipitate, barium sulfate. This is white. PPT means precipitate, short of precipitate. Okay. What about the second one? What? Tell me. Who will tell me?
The sulfuric acid, that is H2SO4 plus copper sulfate.
Okay, copper sulfate. How do you think will be the
CuSO3, sir.
copper will go and take the place of hydrogen? It will replace
Sulfide.
hydrogen. So it will be copper sulfide. Cu S. This is copper sulfide. And hydrogen will go and bond with sulfate. So it will be H2SO4. Okay, this H2 bonds with this SO4 and copper bonds with sulfur to make this one. Okay, so some extra information about these things. This is copper sulfide. And copper sulfide is a black precipitate. Okay. You will understand PPT means precipitate, not PowerPoint presentation. Okay. Sulfuric acid. Okay, so let me write a few more examples. Sure. So I'll write these examples very quickly. If you have any questions about them, you'll ask me, okay? So aluminum chloride reacts with ammonium hydroxide to give you aluminum hydroxide and ammonium chloride. Same displacement reaction is taking place over here. Aluminum bonding with OH to give you aluminum hydroxide. Chloride goes with ammonium to give you ammonium chloride. Most of the times there is white precipitate of aluminum hydroxide, barium sulfate, or silver silver chloride. All of them are white precipitate. So whichever is slightly different, the black precipitate, you have to remember these reactions very well. Try to remember all of them if you want to get 100% in your science. If you want to get 100% of the marks, try to remember all these examples. Okay, this reaction is also again special, important because this is your activity 1.2 in your NCERT book. When you had studied the initial first few pages, you had some activity 1.1. Remember, this was related to the magnesium ribbon burning in oxygen. Then your activity 1.2, what you see here. This one, lead nitrate and potassium iodide solution. What do you observe? So this is your lead nitrate, potassium iodide. This is your activity 1.2. So I will write it as NCERT page what? Page 2, 3 was it? Page 2. So when you want to write that reaction, they might ask you. So this is the one. This is a double displacement reaction, also a precipitation reaction. And yellow precipitate is formed over here. Lead iodide.
Sir,
Yes, tell me.
in the previous example with aluminium chloride, uh, chloride, it can be written as Cl also and Cl3 also, sir.
See, chloride, when we say, it is just a chlorine atom attaching with something else. Now, what it is attaching with, if it is attaching with sodium, you saw an example, sodium has only one electron to share, that's why it was NaCl. So we called it sodium chloride, right? But when it reacted with copper, you see this is copper chloride. Copper had valency 2. So 2 atoms of chlorine bonded with 1 atom of copper. So it was CuCl2. So it was copper chloride like that. But when it reacts with aluminium, which has a valency of 3, that is why the formula is AlCl3. So three atoms of chlorine will attach with one single atom of aluminium.
Okay, sir.
So all of them are chloride only. Whether it's NaCl, sodium chloride, CuCl2, copper chloride, or AlCl3, aluminium chloride, all of them are called chlorides only. Depending on valency, you have a different molecular formula. Here?
Yes, sir.
Okay. Some heavy examples. Let's take a simple one and the last one probably. Yeah. What would be the name of this compound? Anyone can tell? NaOH?
Sodium hydroxide.
Sodium hydroxide. Okay, so you see here what kind of displacement is happening. Na and Cl, they are bonding together to make NaCl, and this hydroxide one is going with this hydrogen. So H and OH, they bond together to make your H2O. Now you see the NaCl, what you get, this is aqueous solution. This is not a solid. So even though this is an example of a double displacement reaction, this is not an example of precipitation reaction. So keep that in mind, okay? This one specifically, it's not an example of precipitation reaction. So what did we understand from that? Not every double displacement reaction is a precipitation reaction, but most of them are. Most of the double displacement reactions gave us precipitates, but not all of them, of course. So the names, this is sodium Hydroxide. Hydrochloric acid, everybody knows. Sodium chloride and water, everybody knows. Okay, so I'm not going to write those names. Okay. Oxidation reduction, that we will take up in the next class. That is the last slide. And probably in the next 2 or 3 classes, we will be able to complete the theory of this chapter. Then we'll go through all the questions. Okay. Take 1, 2 more classes probably, 2 to 3 maximum. Yeah. So today, what did we do? We completed double displacement and precipitation reaction. The next thing which is remaining is oxidation reduction, which we'll take up in the next class. So anyone has any questions? Tell me.
Sir, in the sixth example with lead nitrate, potassium iodide is in the form of what, sir?
Repeat your question again once more. I couldn't hear you.
In the sixth example, sir, of double displacement reaction, where we use lead nitrate and potassium iodide.
Yeah, yeah.
So potassium iodide is in the form of, is
This
it
is
solid?
State you are talking about, so it's in solid state.
Yes, sir.
Yeah, that's why it's a precipitate. So precipitate means it will be solid, just like the previous examples. All the precipitates are in solid state.
No, sir, the potassium iodide before the reaction.
Oh, okay, okay. Potassium iodide, not the lead iodide. Okay. That is aqueous. Okay, I missed that. It's not. It's aqueous. Is that what you were asking?
Yes, sir.
Any other questions, guys? No? Okay, then that's it for today. We'll take up the remaining thing in the next class. Then. Make sure you write down all the notes up to this. Yes, go ahead. Someone had a question?
Yes, sir.
Pragati? Good question, eh? You're asking something? Okay, fine. So if no one has any questions, then that's it, guys. Okay. Make sure you complete the notes before Monday. Okay. Note down everything, whatever in your and note it down neatly, so that on the day of exam you can go through and you can just in one look you will be able to get all these examples in one place. These are very important. And even the lectures before this, the first 6 classes, whatever notes I had shared, that also, hopefully you are copying all those things in your notebook. Are you people doing that, or you have to do everything in this week itself?
Already.
Already did, right? Okay, that's good. Yeah, keep noting down, okay? Because every day I share the PDF in your WhatsApp group. So PDF will not be there for too long. Your parents will delete those PDFs, right? They cannot keep on loading that PDF in their phone. So that you'll have to delete those files sometime. So don't rely on that. Okay. I will upload these PDFs anyway, but see, right now we are only in 10th or 11th class. But after 2 months, we would have had some 60-70 classes. So you will not be able to search for these PDFs. So make sure you keep noting down all these things in your notebook. Don't rely on the PDF. Okay. See you guys then. Bye-bye.
Thank you, sir. Thank you, sir.
Thank you,
Thank you, sir.
sir.
Thank you.